Okay, 2.8.4. This would be a very simple version of that kind of problem. And how am I supposed to know what to put on my number line? It would be an important spot. That question I asked before is still a valid one. 4. Because why? Because it makes the bottom 0. That seems like it's an important spot. I agree. Okay. Now, the stuff on the top, the things that make the top 0, do you think they will be important, given that we're trying to find things that are less than 0? Yes, the things on the top are important too. The things on the bottom that make the bottom 0, they're special because they won't just make it equal 0. The bottom will become 0 and the whole thing will become undefined. Do you remember how I put a U above those? Go ahead and do that right now. Right now I'm trying to get you to map this answer out with me. The 4 makes it undefined. How about the top? If the top is 0, 0 seems important. Wait a minute, 0 should be over here then. Is that one going to make it undefined if I make x equal to 0? No, it's just going to make it a 0. So you put a z above that. Okay, I guess I don't need any other mark out there. So now the question becomes, where does it work for the rest of this number line? I'm going to extend my number line out here. Does it work in here? Well, how do you tell? You check. You test an interval. Okay. So would this thing work at like -1? I'm going to put in a negative and find out. -1, -1, and let's see what we get. We get a negative on the top and a negative on the bottom. Remember how I didn't even care what the answer was? I just cared if it was negative or positive? I get a negative over a negative, which turns out to be a positive. Is a positive number less than 0? No, so it did not work out there. Okay, how about things like 1, 2, and 3 that are between 0 and 4? Do they work? Well, let's test one of them, like 2. Okay, so I stick a 2 in here and a 2 in here, and I get 2 that's positive over a negative. If I get a positive over a negative, overall, a positive over a negative is negative. Is a negative less than 0? Yeah, so it works. And then how about things bigger than 4, like 5? If I put a 5 in, I get positive over a positive. Positive over positive is positive, and positives are not less than 0, so that does not work. The last thing that's important is the points themselves. You cannot just assume that they either both work or don't both work. You have to check each one and think about it. If this has a z above it, that means you already told yourself that it equals 0. If it equals 0, will it be less than 0? No, so it's an empty one. And how about the 4? That's always empty. Know why? Because you have a u above it, and that stands for undefined. And if it's undefined, those will never work. You don't even have to check to see if it's less than 0 or not, because it came out undefined. So that one's also going to stay empty. So it's an empty circle around the 0 and the 4. So you would say 0 to 4 with parentheses. And there we go. So what are the key facets of the problem? A typical question, let's say this one. Let me make it factorable. There we go. First of all, if you can factor it, you should. So everybody factor that bottom part. And then ask yourself, what are the key spots on your number line? Because anytime you have a less than or a greater than sign right here, that's kind of a hint that you need a number line with one of those on it. See? I have a number line now that has a kind of like a less than, greater than on it. So when I see those, I think, oh, that's like the end of a number line. To remind myself, I need a number line for that question. Now find your important spots, circle them, figure out which ones are u's and z's, undefineds and zeros, then test the intervals around it, and then see if you can write me your final answer. It's just like the one I just did for you 2 seconds ago. I'm going to pause while you give that a shot. Okay, so Okay, so how many of you found 3 spots in the number line that were important? Raise your hand if you got that far at least. Okay, good. I'm hoping that what you were thinking was factor this bottom part to x plus 9 and x minus 9. And then those become important spots, and so is that. What do I mean by that? Whatever makes the top 0 and whatever makes the bottom 0 are important. So -6 makes the top part 0. I don't know what the other two was. I guess I know it was +9 and -9 and -6. Those are the 3 numbers that are important. That make the bottom 0 and the top 0. The one that makes the top 0 is a 0. Because if the top is 0, the whole thing's 0. If the bottom is 0, like these guys make it, if I make a 9 or a -9 go in, it'll make them undefined. Those are U's. Raise your hand if you had UZU. Okay, good. Then we just have to test between. My favorite number's in here, it's 0, because I can put in a 0 into the original or the factored one, either way, and it'll test really quick. That becomes 6, and that becomes -81. So it's a positive over a negative. If it's positive over negative, because this one's 9 and this one's -9 makes a total of -81, I have a negative. That's a negative. Is a negative less than 0? Yes, it is. So it works in there. Did you get that? The testing intervals is the worst part for most kids. Okay, then this next part, if I put in a 10, does the 10 work or not? Well, I'm going to put in a 10 here, and a 10 here, and now I have a positive over a positive times a positive, which makes it all positives, which makes it all positives is not going to be less than 0. That does not work. I'm guessing it'll work in one more place, but I better find out which one. I'm going to test -8. If I put in a -8 here, -8 here, -8 here, and I will have a negative over a positive times a negative, which makes a negative over a negative. A negative over a negative will be a positive. Is a positive less than 0? No, doesn't work. I think I did that right. Okay, and then the last part, -10. Put in a -10. This will be a negative over a negative and another negative being multiplied. That makes a negative over positive, which makes negative over positive, which makes a negative, and those are less than 0, so it works again. Yay! Found my other spot, it worked. There isn't always another spot. I just thought there probably would be. And my final answer is from -infinity to -9. And important, the U's are undefined. It never works there. Parentheses. Union with. Do you see how it would be really easy to by accident put a parenthesis there? What's the one spot? Oh, wait. It's a 0, and 0 isn't less than 0. I'm sorry. I was thinking this one worked. It does not work. It's a 0, but in this case, since it doesn't have an or equal sign, it just wants to be less than 0. 0 isn't less than 0, so it doesn't work there either. There are all parentheses. My bad. I thought I was going to have a bracket on one of these. So there it is. Raise your hand if you had the same thing as I did. Awesome. Then you're on track already. Now, you haven't remembered the stuff we did before break. We haven't talked about that yet. I want to do one like that in just a second here, or maybe a couple. But this is kind of the new stuff that you're having. Most of your worksheets like this today. We were just getting into these when you left. So, all right. Now, what would it change if I put a negative right there? Sorry, an or equal to right there. Then the 0 would work, and this would be filled in, and then therefore the 6 would have a bracket on it. The -6 would have a bracket on it like that. That's the only thing that would be different. Make sense? Okay, so how do these get harder? Well, basically, it's just that there's a lot more factoring to do on a typical question. So let's do, actually, I'll do one of these on the worksheet with you in a moment. Let's do some of the review, like some of the kind that you did before break, but you haven't seen in a long time. X over x plus 3 plus, let's say, yeah, let's keep it simple for now. 3 over x minus 3 is equal to 2 over x squared minus 9. All right, so I got a few little rules in math. If I see something that can be factored, I should. So right away, I'm going to go to x squared minus 9 and factor it out, and what would I get? X plus 3 and x minus 3. So now, that tells me that my denominator is really only made up of two things. X minus 3's and x plus 3's. Put them in little parentheses here. Do you remember how to get that cleared, I have to multiply everything by x plus 3 and x minus 3? X plus 3 and x minus 3. And an x plus 3 and an x minus 3. Then a whole bunch of canceling happens. It usually leaves you with a quadratic. Usually the quadratic you have can be factored, and then you get your answers that way from factoring. If it doesn't factor, quadratic formula. That cancels that. X squared minus 3x. I multiplied that out. That and that cancel. I'm multiplying this out now. 3x plus 9 equals that and that and that and that all cancel. Just 2. And now my middle terms even cancel. Sweet. X squared plus 9 equals 2. Subtract 9 from both sides. X squared equals negative 7. Hold the phone. What happens now? When you are trying to take the square root of a negative, you should tell yourself, wait a minute, that's imaginary answers. That means there is no real solution. There are no answers that would work for this one. What's another thing you have to watch out for? What if you get two answers? What happens a lot of times in these kind of problems? One of them is extraneous. Yeah. So watch out for things that don't work. If in this case, nothing works. There was no way to solve the original problem I gave you. You could never make it work. And that's not that it's not that hard to make an equation that has no solutions. Make 3x equal to 4x plus 1. I can do that. Okay, I can solve almost any equation, but not every equation. Can you make 3x equal to 3x plus 1? Nope, you can't. There's a lot of no solution equations. It's just your teachers usually don't give them to you because it freaks people out. So if you ever come out with an answer to an equation that's an impossible thing, like 0 equals 1, then you found one that had no solutions. Then again, there's of course the kind that come out to like this. When is 3x equal to 3x? All what kind of numbers? All real numbers. Yep. So sometimes the solution is no solution, but in this case, when I divide it out and go like this, I get 1 equals 1. Once you're down with just a true statement with just numbers in it, then that must be just, oh, I guess everything works. All reals. As opposed to last time we got a false statement like 0 equals 1, then nothing works. When you get something like 1 equals 1, then everything works. You say all reals. All right, so that was just a quick reminder on how to handle things where they have these complicated denominators. One more kind is a mixture problem. I want to remind you about a mixture problem. Okay? So I like the one with the pop because I think you can all relate to it. We all drink watered down pop as long as you are a kid who orders ice in your pop. That means it's going to get slightly watered down because your ice is going to melt a little bit. Unless you have those plastic ice cubes you put in the freezer, which are kind of neat because then they don't melt. They're just plastic little cubes and they're cold and everything, but your pop doesn't get watered down. But anyway, most people drink watered down pop. And if your pop has been watered down a little bit, most people don't care. So I'm going to say 95% pop is still okay. But I would think we'd all agree that half and half, 50% pop and 50% water, it's going to taste disgusting. So here's my question. If I have 5 ounces of 50% pop, how much pure pop should I add to get 95% pop? Because by then, once it gets to 95% pop, it's going to taste perfectly good again. Okay, do you remember that formula? If you haven't memorized it, that's my job to remind you of it so that you can have it memorized by Friday. Our test is this Friday. Okay, I'm going to remind you right now, it's amount 1 times percent 1 plus, and if you hadn't memorized it, you need to write it. Don't just watch me write it. Write it yourself. That engages a different part of your brain. Better chance you're going to remember it. Amount 2 times percent 2 equals total amount, which is better written as A1 plus A2. I'm going to actually write it that way personally. A1 plus A2 times the total percent. Now, given that equation, would you try to stick the numbers in that I gave you in the right spots? And don't even try to solve it. I just want you to see if you know where to put the numbers. From there, the solving will take a long time, and I don't need you to do that today. See if you can stick the numbers in the right spot. I'm going to pause for a second while you try that. Okay, so hopefully you put the numbers in like this. Amount 1 was 5 ounces. That's the amount. Times the 50% pop, I can put 0.5. Yes, you could put 50%, but you're going to have to change that to a decimal, put in the calculator, right? So 0.5 makes more sense there. Plus amount 2, it says how much pure pop. That tells you two things. How much implies I don't know, so I put an X. Times pure pop, what percent is that? 100%. What decimal is that? That's a 1. Equals A1 plus A2. Well, here's amount 1, here's amount 2. So 5 plus X times total percent. The total percent we wanted was 95% pop, 0.95. Now look, it's just an equation. You can solve equations. This one doesn't even have a fraction in it, so I don't need to multiply everything by the denominator. It's already pretty good shape. I just have to like go 5 times 0.5, half of 5, 2.5, plus 1 times x is x, and then multiply this out, 95% of 5 for probably 495 or something, 95x. I'm not sure what 0.95 times 5 is, but I put some decimal here. And basically just solve it for x. It's not that hard. Just go down, solve the rest of the thing for x. I think you could handle that. All right. Like I said, I just wanted to get this thing into the equation form to remind you. Because if I remind you once today and once tomorrow, and then like on Thursday, you'll remember it. No problem. If I just tell you for 20 minutes on Thursday, it doesn't stick as well. It sticks much better if you do it a little bit at a time. All right. So I'd like to get to the worksheet now. If you all turn with me, find it. It's 2.8.4. 2.8.4. I will pull it up on this screen right here. Okay. Number 1 should be a no-brainer, easy peasy. Number 2, once you get that thing factored, no-brainer, easy peasy. Good for you to practice on the easy ones like that. Number 3 is pretty easy also. Number 4's got a little weird twist to it, so I'd like to do number 4 with you. Okay? Number 4, this is 8.4, or 8 point, what did I say before? 2 point what? 2.8.4. Okay. Problem number 4. All right, so if you can factor it, you should. The top part right here has got a little bit of weird factoring to do. It's not that hard. X just comes out of both things. So x comes out, and I got x squared minus 4. And then that factors again, though. The x squared minus 4, don't forget that, can be made into x minus 2 and x plus 2. So there's the top of my fraction. And on the bottom, I have x squared plus 2. Some kids might beat their head against the wall for 5 minutes trying to factor that, but you can't. You can't factor the kind that are that have a plus in the middle of them. It's not a difference of squares. Okay. All right. So then, all these kind that have a less than or equal to sign, you should be thinking that's like the end of a number line, right? So I'm going to make a number line, and I'm going to identify my key points on that number line. And anything that makes the top 0 is important. Anything that makes the bottom 0. But there's a hint there. The bottom was weird. It wouldn't factor. And I'm not going to be able to find a way to make the bottom 0. So there's just no number on here that we care about then for that. Because you can't make the bottom 0. You make the top 0, though, in 3 different ways. -2 and +2. And that is the last one. What would make that front part 0? 0. So many people forget that. Because this part right here, that's another 0. There's 3 roots to this thing. That and that one can be made 0. Okay, so then I got to circle those spots, and those are all 3 on top, so they're all zeros. Z, Z, Z. In this particular problem, if it's zeros, then 0 will equal 0. Notice there's an or equal to sign, so they all work. Fill them in. And now it's a matter of testing intervals. The part that I have found kids make the most mistakes on. So, all I can ask is that you be really careful when you test your intervals, because it's very likely you're making a mistake. Probably 50% of the people have at least one problem on the test that they screw up the intervals on. So you can figure, I might be making a mistake here, so I better be careful. I'm going to test 3. If I put in a 3, do I even need to test the bottom? Can't you tell by just looking at it, no matter what I put in, the answer is always going to come out to be a positive number? It's true. Because if it says like something squared plus something, you cannot make this thing that's getting squared ever be negative. It's going to always get squared, so it's going to come out positive. So the bottom's always positive. Always, always, always. The top, though, depending on what I put in, I could make negative. By putting in a 3, I'm making it positive, positive, and positive. Positive, positive, positive over a positive is, of course, going to be totaling up to a positive. Are those less than 0? No, they are not. So there's a lot of work to doing those testing intervals. I see why kids get them wrong. If you make any mistake along the way, like you think one of them is negative and they're positive, it's all wrong. Okay, now I'm going to test 1. Putting in a 1 here and here and here, I'm going to get positive, positive, negative. And on the bottom, it's always positive. So, now what some teachers do, and I think I like this, is they put the work for this right underneath it. Plus, plus, minus over plus. And that shows me that I got a negative on the top and nothing to cancel it, so the answer is negative. And negative numbers are less than 0. So it worked. Now I'm guessing it's not going to work in the next one, but that's just really guessing. I got to test -1 and see if it works or not. So now, if I put in a -1, I have negative, positive, negative. That was from me putting in a -1 here and here and here. I got a negative and a positive and a negative. All over, again, the bottom's always positive on this problem. So this one has 2 negatives, which makes it positive. Positive over positive is positive, and positive numbers are not less than 0, so it doesn't work. The last thing, I really don't know if this is going to work or not, because sometimes we make it so it doesn't work. Let me check the -3. So I stick in a -3. That's going to be a negative. I'm putting the -3 over here on those 3 spots. Negative and a negative and a negative. That's negative, 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 all over positive. That does come out to be negative, which means it is less than 0, so that means it works. Final answer, from negative infinity to negative 2, bracket, union with, from 0 to 2, also works on both ends, brackets. All right, there's one more kind of problem I want to show you that's on the hard side, and it is about finding common denominators. So let me go there with you. Hopefully you're following along with that one because I just cleared it. You can always go back and watch the video later if you want to. Let's look at number 8, for example. It's different than all the other ones. All the other ones were multiplies or fractions like this. You know, there's no like different terms. Here we have two separate terms. X squared plus 4 over x is greater than or equal to 0. Now it's going to be really tempting to multiply everything by x, but we are not allowed to do that on an inequality. Reason? If I had something simple like x is greater than 3, if I multiply by something negative, do you remember I have to switch the sign around? If I multiply by something positive, I don't. So if I multiply by a variable, do you get you can't tell whether to switch the sign around or not? Because if I multiply by a variable, I don't know if I multiplied by a positive or a negative. So that's why you're not allowed on this problem to multiply everything by x, because it's an inequality sign, and I don't know whether to switch the sign or not then. So you're not allowed to multiply everything by x. So how the heck are you supposed to do it? Let's see if we can find a common denominator for this and this. Would you agree that x squared is really x squared over 1? Does that make sense? And this one's got a denominator of x. If I want to make them have a common denominator, then the common denominator I should use is the x. So how do I get this guy right there to have a denominator of x? I multiply this by x, and I multiply the top by x. Because effectively, then, I'm just multiplying by 1 creatively. X over x is equal to 1, right? All right, so now I've got x to the third over x plus 4 over x, which now have a common denominator and therefore can be added together. And that's really x to the third plus 4 over x. Now, do you get that now I can do the problem just like I always have done these problems? You get how it's down to 1 fraction now? So now I can just say, okay, looks like one of these kind of problems. I make a number line, I find the important spots. See what I mean? Now that I've added them together and got a common denominator, this problem looks like all the others. Top won't factor nicely, but that's okay. Just means I can't find the zeros easily. All right, so the things I look for are things that make the top 0, things that make the bottom 0. One that jumps right out at me is the bottom, that x. I better not let it be 0 or it will be undefined. So that's an important spot at 0. Now, are there any other spots that could make the top 0? Is there any way to make the top 0? Well, I better solve an equation and see if I can. Can x to the third plus 4 equal 0? It's just a little math problem. So you subtract 4 from both sides. X to the third equals negative 4. Can that possibly happen? With something cubed, you can have a negative. So yes, there is a way to make the top 0. So I go, how do I get rid of this cubed? You can put it to the 1/3 power, also known as cube root. And I'd have x equals the cube root of negative 4. Whew, that's nasty. So the cube root of negative 4 also looks like this. Do you get that it's some number bigger than 1? That's like negative 1 point something. So then I know it's like negative 1 point something. I'm going to call it cube root of negative 4. I really shouldn't have the negative on the outside, but I know it's going to be negative. Blow that up a little bigger. That spot right there is the cube root of negative 4. Now, that's an important spot. It's a 0. Will the 0 spot be greater than or equal to 0? Yes, it will. It works. Now I've got to test on both sides of it, and from here it's easy. It's just testing intervals like you're used to. So the moral of the story is, when you have two things being added together, you can't proceed until you've actually added them together with a common denominator. Once you got a common denominator, they're like all the other questions. Just this one happened to be hard to solve because it had a cube root in it. All right, let's move to another one that's kind of like that then, and see if you know what to do on number 9. I do not want to do number 9 all the way, but I want to see if I can help you get the common denominator for number 9, because it's one of those kinds where you have to add them. We cannot multiply both sides by x plus 2 and x minus 1. Why? Because it's an inequality, and that's not allowed for inequalities. So common denominator. If I could get those to be a common denominator and get them down into one big fraction once I've added the two things together, then it's going to act like all the others. So you'd multiply to get a common denominator. I need to multiply by x minus 1 here. And I need to multiply by x plus 2 here. Now do you get that the denominator is the same? And now once you're done multiplying that all out, you'll have a big fraction. And now you can do the problem. Just like I'm doing the top here, all over the denominator, which is x plus 2 times x minus 1. You can multiply it all out if you want, but then you're going to have to factor it again. So you may as well leave it factored. So now I'm down to one of these kind of problems, which you know how to do. You set a number line, you find the important points, you know, negative 2, positive 1. This can be added together. You get 2x. Those two put together make a 1, 2x plus 1 on top. And then that part can be equal to 0. And on the bottom, I get two things that would make it 0. So there's three important things. The thing that makes the top 0 and the two things that make the bottom 0. Those three important things, you have test intervals around it and stuff. All right, I know it's hard to get back in the groove, but if you think of yourself as like you kind of think you understood today, that's probably a good sign, because we'll have one more day of new material tomorrow, 2 days of review on Wednesday and Thursday, and then the test will be Friday. Okay. There is some word problems in here. Keep in mind, when you're making word problems, you're really making equations. Once you're done making your equations, it's really not too bad if you've got two equations. That's how you're used to doing problems with equations. One more I'd like to look at is number 10, just because it looks weird. The zeros are still important. It's got a greater than or less than sign, so I need a number line. So I got to find the two important spots. Pretty quickly can tell that 2 is an important spot. And then what the heck's important over here? Whatever makes it 0. Okay? So then I have to say what makes 3x plus 5 equal to 0. 3x equals negative 5. X equals negative 5/3. Then you got to ask yourself, when you're testing your intervals, whenever you square something, do you get it's always going to come out positive? Whenever you absolute value something, do you get it's always going to come out to be positive? And if it's always going to be positive, and it's always going to be positive, then do you get this thing always has to be positive, no matter what? So when is it ever going to be less than 0? There you go. No reason to test all of those spots. Because even if you get spots to make it equal 0, these two spots make it equal 0, but they're kind of irrelevant, aren't they? Because if it equals 0, it's still not going to be less than 0.
Did you say all reals then?
No, not all reals. I think you got it backwards. If this is always going to be positive, is it ever less than 0?
Oh.
So instead of the opposite of that, instead of all reals is no reals, no real numbers. Okay, probably gave you a little too much help today, but I feel bad for you since you've been gone for 2 weeks. So, all right, that's all I have for today.